Acoustic levitation is one of the exciting new technologies emerging from modern physics. It is the manipulation of high-energy sound waves to suspend matter in the air using acoustic radiation pressure.
There are four key elements to a wave.
The amplitude, which is the amount the sound wave has moved an air particle from the position it would otherwise be. The peak, the trough, and the frequency, which is how often a second a wave cycle is completed.
But how is acoustic levitation possible? And does it work in space? Well, no.
Unlike electromagnetic waves, acoustic waves are longitudinal and require a medium such as air to travel through. In longitudinal waves, the direction of particle movement is parallel to the direction of energy flow in the wave, and in sound waves, this creates a moving front of increased air pressure. When two such waves pass through each other, wave superposition occurs. This says that the resulting wave in space is the same as the other two waves added together.
Through the superposition of waves, a standing wave can be created. In a conventional traveling wave, the crests and the troughs are constantly moving. However, in a standing wave, the crests and the troughs occur exclusively at a point called the antinode. There is also a node, or a place where there's no change and the wave has no amplitude.
Between these two silver ultrasonic speakers, two separate sound waves are being created at the frequency of 40,000 Hz. Through superposition, these form a standing wave between the speakers. This particle is sitting in one of the standing waves' antinodes, where pressure is constant but fluctuating around it. Let's look at one complete wave cycle. Throughout half of a wave cycle, there is an area of high pressure above it and an area of low pressure beneath it, pushing the particle downwards. During the other half of the wave cycle, there is an area of low pressure above it and an area of high pressure beneath it, pushing the particle upwards. This process is repeated 40,000 times a second and keeps the particle perfectly centered in the wave's antinodes. Thus, the particle levitates, held up by the pressure of sound. This technology is exciting and it is new. Currently, it is being explored for use in containerless chemistry, contactless electronics assembly, as well as in hologram technology. Having the ability to hold things in suspension is pushing humanity ever closer to the next big breakthrough.